Our next speaker is going to be Jack Firth, who is going to be talking to us about his opinions on testing and improvements that we can do for testing in Racket. So thank you, Jack.
Okay. Testing. There we go. I promise I didn't plan that. I wouldn't deliberately torture you. So this talk is about a toolkit of RackUnit packages that I made. And RackUnit is Racket's standing testing framework. And I wrote too many packages, so I'm going to have to go pretty fast. I really love RackUnit. I use it all the time when I'm writing Racket code, and it's just very, very easy and simple to use, and it's just a very seamless tool. But it doesn't handle complex stuff as well as I would like. So I wrote too much code. I made a bunch of packages that handle a couple of different independent kinds of tests that I wanted to be easier to write. And you don't have to use any of them together. They're all independent. But considering this is like a run-of-the-mill factorial function that anyone might write. And we have a module, we provide it, we implement it, and we want to be sure it's correct. So we write some tests. And we can do that with RackUnit by just adding a test submodule, importing RackUnit, and then writing some checks that say, pass this input, get this output. We are done. That is all you need to do to get started with a test. And the RackO test command line will take your file, run the tests, and tell us that we screwed up. Because as it turns out, it was giving the factorial of 4, it was giving us the factorial of 3. So the failure output is generated by RackUnit, and it includes the actual and expected and the name of the test, as well as source location information. And that's possible because RackUnit checks are actually macros that will grab reflective information about where they're called and include it in the test output. Oh, and Dr. Racket runs these tests for you too, and it shows them right in the window. So we go back to our tests, and we fix the bug, and there we go, we're done. And it might seem weird to have the tests in the same file, but Racket has submodules, which means that although they're in the same file, they're two separately loaded modules, and the dependencies of one are not the dependencies of the other. They're independent. So a client can import just the code or just the tests, and you don't have to force all clients of your module to have a dependency on your testing framework. So this is awesome. This is everything I want. It's really easy to write new tests. I can just go into any random file in any project I know nothing about and go and just write some checks. I don't have to figure out their directory structure. I don't have to figure out the commands and tools they use to run tests because it's all pretty standard for Racket, and Dr. Racket will just do it automatically when I press run. And it's really great for collaboration and doing things quickly and seamlessly. But there are some limits here. RackUnit gives you a couple of basic checks out of the box, but they don't do much more than simple comparison tests. Like, are these things equal? Does this one satisfy some predicate? Or does this thing match a pattern or a regex or stuff like that? You don't get much in a higher level. You can't really write it doesn't give you a lot of checks for things like, will this string parse as a language with a syntax error or not? So how would you test things like, does this function log to standard out? Does it log messages? How do I test network calls and mutation and all sorts of fun stuff? Because I really wanted to test those things. So RackUnit gives you a define check macro for writing custom checks, and you won't like it. Because checks are, in RackUnit's model, just functions that either do nothing or they'll throw an exception that contains some random key values for failure information. This means that if you call another check, it will generate information based on where it was called in your function, not where your outer check was called. And that's good for some bits of information and bad for others, and it's not really always clear how to combine them. And furthermore, just using exceptions for control flow in general is a real pain to abstract over. Like, It's hard to kind of make sure that you're doing things in the right evaluation order, and it's not fun. So that's the problems with custom checks. And they do not work if you want a custom check form that is not a function. If you want a custom check form that behaves like a macro, there is no API for that. You have to go into RackUnit's internals and figure out how they do it and copy paste code, which is what this check match form from RackUnit is actually implemented as. Yikes. That is not fun at all, and I don't like writing that. So there's another aspect of RackUnit that has some interesting consequences. It has test cases and suites that you can use to control how checks are evaluated. So I can group a bunch of expressions, and if one of them fails with a test failure, the rest of them don't get run. Pretty simple. However, this simplicity is kind of hard to, it has some things about it that will surprise you. You might have already seen this one coming. If a check fails, you don't get automatic cleanup action because you aren't expressing that there's a resource you want to clean up to the test. You're just writing expressions. Even stranger, if you nest test cases and a nested case fails, it swallows the exception and later checks in the outer case keep going. Yeah, I had a real fun time finding that one out. So I just said, screw it, I'm going to write some testing libraries because I had stuff to do and I didn't want to waste time trying to replace RackUnit now that it's in the main distribution and all Racket code on the planet uses it. So here's some libraries I made. First, I made a library for writing test mocks. And you can install this as racco package install mocks. And a mock is a function that will spy on however it's called and keep a list of every way it's been called. So you can make a mock and give it some behavior function that says how the mock should respond to calls. And then you call it, and it acts just like the behavior function. But later, you can use mock calls and get a list of everything it's been called with. And there's a little argument structure that just represents bundled arguments. I made another little package for that too. So if you ever find yourself wanting that, there you go. Included in the mock package is a way to automatically replace functions with mock implementations for tests. Here, we just have a little function that prints a friendly message trying to communicate with humans. And testing the output is something that we wanted to kind of do simply and easily, so we mock out display line. And we say that in the mock behavior, it should be called void and do nothing at all. So if you call it normally, it does the exact normal thing you'd expect. But if you introduce a with mocks use, it will pull off static information from the friendly AI identifier and bind all of the internal implementation stuff to mocks, bring them into scope, and now when you call friendly AI, it only goes to the mocks, and you can inspect the calls made to those mocks for testing. I like to think of mocks as the Ditto Pokemon of testing, because really when you're using a mock, you're saying, I want to test how I'm calling this thing, not what it's doing. So it's really great if you don't have a good way to test what something is doing. Like you're working with some external API or some library that wasn't really designed with testing in mind, or something that requires you set up some sort of expensive resource, or something that like you need AWS keys to do. So it's really great as a substitute for the real thing. So that was the first problem I tried to solve. The next one is I wanted to deal with integration testing. So I made a package called Disposable, and this was a way for me to abstract over creating and destroying stuff, especially stuff that involves I/O and to external resources and other systems, like a row in a database. So a disposable value is a pair of a way to create something and destroy something. So here, if we have a way to create a universe and destroy a universe, we can join them together into a disposable universe. And with this, we can go and make a bunch of universes in a whole bunch of different ways. We can say, just for this set of expressions, make a universe, and at the end, or if there's an exception, destroy it. Or we can say, give me a universe until this event fires. So here we use it for a timeout. Or you can say, just give me a universe and clean it up right before the program ends. We can also compose disposables, and they compose as monads. So if you happen to have a way to make a disposable galaxy in a universe, and you have a disposable universe, you can chain them together, and now you just have a way to automatically make a disposable galaxy in its own isolated universe. Voila. Just monoids in the category of end-defunctors. Now, because disposables offer an abstract API that it gives you a lot of options, you can also make an automatic pool of disposable values. If you've ever seen connection pooling, it's where, since connections to things can often be expensive, if you're going to create and destroy one, instead you return it to a pool and reuse it in the future. We can do that with any disposable. So here, we're making a pool of disposable universes. Say there should only ever be 10 in the pool at most, because we don't want to keep 10 universes in one computer's memory. Not really sure how well that would do. And we don't want to keep more than 3 around for new customers. So we can take this pool disposable, and this is a disposable that will give you a pool. So we acquire the pool globally, and then this pool is itself a disposable that you can use to get a value from the pool. So here, we have a global pool that will be cleaned up at the program exit and destroy all the universes, and we have a way to lease values from the pool with disposables. So this might not seem like it's related to RackUnit directly, but that's where my third package comes in. Fixture. Here, we're going to hook together disposables and RackUnits and do some cool stuff. So if you have some disposable, you can define a fixture for it. And then, in a RackUnit test case, you can declare fixtures that you need for your test. And in that test, you automatically get a current whatever that's used and created for your test specifically. And if your test fails or errors or whatever, it will be cleaned up at the test exit. Now, on its own, this isn't really much better than just wrapping it with disposable, but fixtures will do it once for each test in a set of nested tests. So instead of having to manually declare that each test here uses the user fixture, I just wrap them all in a super test and then declare it once, and the boilerplate is gone. So now there will be 4 users created here, 1 for the outer test, and then 1 for each of the inner tests. And disposables also integrate with RackUnit's check-info system, so you can say how a disposable should print and show in a test failure. So if we have a way to, from a user, give you a nice string representing who that user is, instead of some weird opaque struct or something, we can attach that to the fixture. And now when this check true false thing fails, we will get the list of all fixtures in the actual failure output. So this is collected automatically for all fixtures in the test case chain, not just the ones in the closest one. So fixtures on their own imply you're making one of these things for every single test case, which can be expensive. So you combine them with disposable pools, and now you can appear to make a giant pile of resources for every single test that's isolated and not used by anybody else, but they're reused between tests, giving you faster tests that you don't have to do a whole bunch of database I/O. Voila. That's all I wanted to do. So I went and did all that and had a great time, but along the way, I just kept thinking, this is really a pain, because I have to make RackUnit checks and integrate with Racket's notion of dynamic parameterization of how tests are executed, and all this very imperative indirect stuff. And I found it very, very frustrating. So I got one more package. Expectations. An expectation is a pure functional representation of an assertion. And the idea is that in RackUnit, the central problem is that the checks don't really give you much information to other checks. It's very hard to cross-communicate and do useful things across multiple checks. It's hard to compose over them and abstract things. But what if we split responsibilities? And we have the check just be responsible for the sort of integration with the testing framework, sort of macro-y stuff where we capture location, all that sort of thing. And then we have this expectation responsible for all the logic of whether our test passes or fails. So here we have this expect equal value, and this will create an expectation. And here you can apply an expectation to any input, and it gives you a list of faults. And expectations are just pure functions that do plain pure functional things. So this, not really easy to read, but when you use it in check expect, it renders like this. And here we see the original subject that the whole expectation was applied to, that list. We see what it expected and what it got, but we see that in a context. It is nested in the piece of the list for you automatically so that you don't have to see a big giant diff of two huge data structures. It will narrow down the specific parts that are wrong. And this works even if there's multiple different failures. It will give you multiple different things it expected in different contexts. So let's take a closer look at what those faults are. A fault has a summary. It's just a little string describing it. And it has an expected and actual attributes. Instead of just plain values, they are attributes that are some abstract representation of some property of the input. And the reason you want to do this is because you can't always test things by saying you were looking for a certain value. You might have been looking for a set that has this in its, this as a member. Or you might want to say, I was looking for some value that matches this predicate. So those sorts of notions become different attributes. And a fault also has this list of contexts, and contexts are, again, structured data that represent where in the fault you are. And the reason it's all structured instead of strings is because that way, expectations can use other expectations faults and abstract over them and do things with them. So here, let's look at this case where we have an expectation that says, I want a hash that has a foo key mapped to any set that is a subset of this thing. So it's not just a simple equality test anymore. And this is where it gets much easier to use than, I don't know how I would write this test with RackUnit. That would be quite an adventure. So here, we can look at the failure output and see that the actual set it found was 132, and it expected that 3 would not be in it because that wasn't in the subset originally. And it tells us that it was in the context of the hash key value. So because expectations use these heavily structured representations of errors, we can combine them in very fine-grained and abstract ways. For instance, we can take a list of expectations and combine them into one that applies them all and returns all the faults they found together. Or we can say, I want to take a function, pair it with some arguments, then take that thunk and assert that it raises something. Or I want to say, I'm going to take a syntax object, make a thunk that represents macro expanding it, and assert that that macro expansion returns something. Or, and there are other things you can combine too, like you can compare identifiers pretty easily. Now, that's what I have now, but what I want is I want this to go nuclear in terms of interesting expectations. For instance, you should be able to say, I want to check for all values generated by this thing that all of them satisfy this expectation. And now I have a way to do property testing and other sorts of like soft verification things. Or I want to say, I expect a function where when I give it these inputs, it runs in quadratic time, or it runs faster than this other implementation of the same function. Or I want to abstract over other sorts of things, like I want to say, for the set of all transitive dependencies in a package, I want to expect every one of them has a license so that I don't get in some hot water. And there are all sorts of things like this you can write, and I say you because I want you all to write them, not me. That's too much work. And I really want expectations to be something that you can build this sort of stuff on pretty easily and extend and make new fancy libraries, and you won't have to touch custom imperative RackUnit checks nearly as much. And that's all I got. So. I guess we do have a little time for questions. Very good question. It was, why did I make disposables when Racket has a notion of management of resources through custodians? And the reason for this is that disposables are a very different use case than custodians. Custodians are for resources that are external to Racket, but Racket kind of owns interacting with them, like memory allocated manually, or other sort of runtime internal stuff, because when a custodian shuts down, the shutdown code run by the custodian is run unsafely in atomic mode, doing all sorts of evil, gross things. So it only works if you have things that you know you will always be able to clean up. Disposables are for things where you're talking to external systems, like a database or an HTTP API or God knows what. And you do not want to do that in atomic mode unsafely. So this is for very much just external resources that you kind of have to treat like things in a distributed system. For instance, although disposables give you an API where you won't forget to destroy things, you can't guarantee you'll be able to clean something up in a database because the network could go down. Who knows what could happen? So actually, when you do a global acquiring of a disposable, this is why it uses Racket's Plumber API, not custodians, because Racket's plumbers are for this sort of soft cleanup of things that you can kind of abandon and won't require unsafe actions. I have a couple GitHub bugs open where I've written, The question is, some of the stuff expectation does is very similar to some of the stuff contracts do, and some of the stuff closure spec does. The thing contracts do that expectations can't is contracts can do higher order checks where they have a boundary and blame and all that sort of stuff. But the flat data checks that expectations can kind of do and closure spec does, those are very related. And I do have some ideas of how to take an expectation and turn it into a flat contract and maybe sort of reuse some of contract's error messaging logic to kind of make pretty contract error messages. But it's just sort of hypothetical stuff I have notes of on GitHub, not like fleshed out. Yeah, that's there. It's under expectation conversion in the docs. But the gist of it is that anywhere the library expects an expectation, like the check expect check, you can just pass in a data structure and it will convert that using the equivalent expectations. And if there's nested expectations inside the data structure, it will use them. So you can say, I'm going to just pass a list of 5 things and 4 of them are data and the 5th one says I want this thing to be even. And that will just magically work.